Hey, we're looking at section 5.3, and we're going to look at other trig functions. And we're going to define the other trig functions in relation to the unit circle. So there's other ways to define these, but we're taking a unit circle approach. So if I have an angle theta, and this is a unit circle, and we have a point xy where the angle, terminal side of the angle meets the unit circle, then we define the trig functions as follows. Tangent theta is equal to y over x. So you take the y coordinate divided by the x coordinate, that's tangent theta. And we also have secant theta. And secant theta is 1 over x. Cotangent theta is x over y. And then cosecant theta is 1 over y. So I guess obviously I abbreviated, but maybe I should write these out. This is tangent, and this is secant. I have cotangent and cosecant. So, okay, there we go. So that's how those are defined. And so for an example, a point on the unit circle corresponding to theta is negative 3/5, 4/5. So let me just draw that. Find tan theta, secant theta, cotangent theta, and cosecant theta. Okay, so tangent theta is y over x. So this becomes a little bit of a question of working with fractions, but it's totally doable. Secant is 1 over x, so that's what we have here. Cotangent is x over y. Cosecant is 1 over y. So that's our answer. Okay, so that's their point there. That's the answer. All right, now let's try to find those trig functions of points on the unit circle. Let's just do some examples. Let's find some of those trig functions of angles. Okay, evaluate. So let's look at, say, tangent 5/4 pi. So here's our solution. By the way, I have some ideas of how to do this a little bit better than what I'm doing here, but we'll get to that. Okay, so first of all, I need to write this. I need to locate where 5/4 is. So find 5/4 pi on the unit circle. And the way I do that is I use as a reference the x-axis. So I'm going to write this as 4/4 here. So if this is 4/4, I go 1 more fourth and get 5/4 pi. And then what I do is find the reference angle. And the reference angle, truthfully, if you're doing radians, you just look at the denominator. That's 4. That's going to give you this 5 pi over 4. Okay, so what we do is then is we can draw the triangle. You can just draw it there like I did there, but you sort of run out of space. That corresponds to pi over 4, which is 45 degrees. Okay, now I'm going to introduce something. Is that if you saw in the last example, there was some working with fractions, which was a little bit difficult. That's not that hard. But if I multiply by 2, actually, see, this is 1 over rad 2. Not by 2, but if I multiply by rad 2, another way you can see this is that you have 1 times rad 2, and you can set this circle, this triangle up this way. This is for 45 degrees. Why would I do that? Because I think it's easier if I look at this type of triangle to see what's going on. And when I do this, the problem is that there's issues that this triangle does not have a hypotenuse 1. But when you're finding tangent, for example, it can be easier. Okay, I'm going to just not go into that yet. I started on this, but now I'm seeing I better hold off. But anyway, I'm going to take this over here. I'm going negative rad 2 over 2. It's not the distance, but I'm directing it to the left, so I'm going to do it like that. And so I look at, and so you can find the reference angle, label that, and you get the point, negative rad 2 over 2, negative rad 2 over 2. So then you get tangent 5/4 pi is y over x. And that's negative rad 2 over 2 divided by negative rad 2 over 2, which is positive 1. So the issue I have is with these fractions here when you're doing something like tangent. And I have another way to explain this that I started going down, but now I realize I'm just going to hold off on that just for a little bit. But if you use this triangle here instead of this one, see, you get 1 divided by 1. It's easier to look at. Nothing else. What was that? That was A. Let's just do one more. B. Let's find cosecant 5/6 pi. So what I'm going to do is I'm going to have this as pi, and I write this as 6/6 pi. So locate 5/6 pi, find the reference angle, and I can really just look at that denominator of, okay, here's 6/6, I back up and you get 5/6. And then I can look at this guy here, that's going to be pi over 6, it has the same denominator there. And then I try to remember what this triangle looks like. Pi over 6 is the smallest angle in this 30, 60, 90 triangle. So it's going to be opposite that will be this shorter side. Over here is the longer side. So I'm going to get that this is rad 3 over 2, 1/2. So the point becomes negative rad 3 over 2 because I'm going to the left, and then 1/2 going up. So then cosecant theta is equal to 1 over y. So it's cosecant 5/6 pi is going to be 1 over, well, y is 1/2. So therefore that gives 2. It's sort of involved.